All right, I am going to quickly run through this thing. I'm not going to do all of them here. Okay, I'm going to do the ones that I did in class, and it'll be up to you to try to do the other ones. Okay, so I do the A's, you do the B's. So here I've got a multiplication problem of two radicals. They're both square roots, so I can multiply. And they just go underneath the same radical. And then I just got to simplify that. You don't want to multiply it together. What you want to do is keep it in this factored form so you can find common factors. So 48 is 6 times 8. And remember, I'm doing square roots. I need two of a kind. Remember, 8 times 8 is 64, and 64 can be square rooted. It's just 8. So whenever you see two eights, or two of anything in this factorization, you can grab those two, bring out that number, cross it out because it's no longer inside that radical, and then write the result of what's left inside. And there we go. So it's 8 root 6 is our answer. That's all we got to do. Okay, this is the property of radicals for multiplication that looks like this. And so what this says here is that if you have the nth root of some number times the nth root of another number, it's equivalent to the nth root of the product inside there. That's a really kind of rough looking a times b, so I'm going to rewrite it. So it would be nth root of a times b. And so this was like my a here, this is like my b, and so this is now under the same radical. And it is a plus b. See if I can undo that. That's not helping me much. All right, let's keep on going here. So 2a now. So in 2a, I'm going to use the following rule that a to the negative m power is equal to 1 over a to the positive m power. So the 16, this is my a. This negative 5/4, that's this negative m that we're talking about. Okay, and it just says this is going to be equivalent to 1 over, so I go 1 over the a, which is our 16, to the positive m power, so now it's positive 5/4. So that's how we deal with negative exponents. I mean, give me the reciprocal. Okay, so this a to the negative m is like over a 1, and then you flip it over, and then you flip it over when you get rid of that negative. Okay, so negative exponent means give me the reciprocal, and now it's no longer negative. If you leave it negative, it means flip it back over, and we don't want that. Okay, so let's finish this thing up here, and I'll speed up a little bit. So we still have to work out what this does to the 16. You can just run to your calculator if you want to and try that out. Right, that might be our first attempt. Find out if it is a perfect 5/4 root. Right, so I'm going 16. I use the caret button, the button that looks like this, to type in 5 divided by 4. Oops, missed my 5 there, so 5. Start again, 16 caret 5 divided by 4. There we go. Hey, that's just 32, so that's 1 over 32. Now, we should also be able to do this by hand, so just real quick, that 5/4 means the 4th root of 16, and then take that answer to the 5th power. Well, 16 is made up of 1, 2, 3, 4 2's. 2 times 2 times 2 times 2 is 16. So it's a perfect 4th root, so a 2 comes out. If I take it to the 5th power, it's 32. So that's where that 32 is coming from. Okay, but our calculator can figure that out for us. But we do need to know how to do it this way, just in case, if I ran this through my calculator and it gave me some decimal instead of an integer like the 32 was, then that means it's a radical, and I'm going to have to simplify that radical. Much more complicated problem then. All right, get rid of my calculator. Let's look at 3a here. So in 3a, what you should notice is you got a 4th root of the entire fraction here. And so, normally what we do is we say, hey, if you've got a fraction under your radical, separate it, because we don't want fractions under the radical. And so that's what we have here. But before you should separate it, you want to simplify it. Okay? Because if it simplifies, then you can square root or 4th root, in this case, something similar or smaller. simpler is what I meant to say. So let's start simplifying here now. I'm going to rewrite this just so you can see what it means. You don't have to rewrite this by any means, but this is the same problem because these are just a bunch of things multiplied together. Like on top it's a 64 times an x to the 10th. But on the bottom I can put my 4 under here and I can put my x to the 6 under here. I can just break up these fractions or these products and I don't want to because it is all multiplication. So like when I write it this way, that's still 64 times x to the 10th over 4 times x to the 6th. And I still have one more in here I'd like to do. I want to do this 1 over y to the negative 8th. And so by writing it like that, I could see, I could use the first rule here. I could work this way. I could separate each one of those. Okay. And so if this helps you, you can. Now, you wouldn't have to show this because what you're going to end up doing is exactly the same as just simplifying inside that radical. But this way you can see a little bit better maybe what's going on. Fourth root. So let's just simplify each of these individually. Well, this is the fourth root of, let's see, that comes out to 16. 64 divided by 4 is 16, and the fourth root of 16 is just 2. I've got the same bases, and they both have exponents, so the rule is subtract the exponents, so 10 minus 6 is 4. So this comes out to the fourth root of x to the fourth, and that's just x. What is multiplied together 4 times? And in here we have x multiplied times itself 4 times, and so the answer is just x. Again, you can just think of these lots of times as that 4 divided by this 4, and whatever that simplifies to, it tells you how many x's can come out. In this case, it simplifies to 4 over 4, 1, so x to the first. All right, then our last one here, see here, I've got myself a, I've got a fourth root of a 1 over negative, is that negative 8 there? And we just saw that negative exponents mean give me the reciprocal. So if I'm in the denominator and I do the reciprocal, then it goes to the numerator. And it does change the sign to a positive 8. So I've dealt with this guy. He's done. That's the 2. I've dealt with this guy. He's done. That's the x. I just got to figure out what this last factor simplifies to. A couple ways to think about it. The easiest is to say, well, this is the same as 8 over 4. There's your exponent. There's your index. And so that just simplifies to y squared. And you can see it's not like it's y over something. Okay, the denominator here underneath that 2 is just a 1, so it's not under the root anymore. It'd be like a 1th root, but we don't do 1th roots. Okay, so it just simplifies to y squared, and that's what it is out here now, y squared. The other way you can think about this is the following. You know, when I have y to the 8th, that's 8 of these y's. And if I take 8 and divide it by the 4, this index 4, it tells me 8 divided by 4 is 2. It tells me how many groups of 4 I get. 8 divided by 4 is 2. I get 2 groups of 4 y's. And each group lets me take a y out because they are 4 of them multiplied together. So a y comes out, a second y comes out, and that gives us that y squared. So there's that guy, there's this guy. See here, 4a, 4b. These are addition problems here, but my radicals are different. They need to be the same radicals. Now, it doesn't mean I can't subtract them. What it means is I have to simplify both of them to see if they are like radicals. Now this one, the second one, I can't simplify. It's got a 3 there. It factors this 1 times 3. I don't get 3 of a kind. Nothing comes out. Okay, no perfect squares in that. But let's work on this 81 now, because 81 certainly has some things in it. It's 9 times 9. And each of those 9s is a 3 times 3. Okay, and so we're doing cube roots here. So I can circle 3 of those. That's a 27, which can be cube rooted. Or think of it as a 3 cubed, and you're cube rooting it, so these cancel, and you just get 3. Either way, a 3 comes out. So we got the 5 on the outside. Out comes that 3, just a single 3, because we cube rooted it, saying, hey, it's 3. That's multiplied together 3 times. And then I'm left with the cube root of, let's make this last 3 red so you can see him right there. Okay, so that first simplification yields a 15, 3 times 5 or 5 times 3, cube root 3. But don't forget about this little guy up here. We've just been ignoring him because he couldn't be simplified. I'm just going to carry him down here. So now I'm at this point, and I still have this minus 2 cube root 3. And if you notice now, when we simplified it, they do turn out to be like radicals here. So this says I got 15 cube roots of 3, take away 2 of those cube roots of 3, and that would just leave you with 3 of those cube roots of 3. So there is our 4a. All right, let's see here. Skipping over the b's, those are up to you. I'll pause right there if you want to get a picture of it or whatever to refer to. All right, 5a, now we are solving for x. Okay, these are all radical equations, so you can see I've got an x right there underneath the radical. That's what makes it a radical equation. Step 1 is make sure the radical is alone. It is. Here's the equal sign. The only thing on this side is a radical, and underneath it's some expression. Okay, but the radical itself is all alone. Over here, there's nothing added, no multiplications in front. So once the radical's alone, we just square both sides in this case. Remember, this is a square root, so we square the sides. And this guy now is x plus 1 times x plus 1. We squared the side, which means take the side times itself. And on this side, when we do that, these 2's just end up canceling, and we end up with 9 minus 2x. So let's multiply this guy out here, just doing our distributing there. 1 times x, or x times 1, then 1 times x here, 1 times 1 there, giving us a total of x squared. There's 2 x's in the middle, plus 1. Equals 9 minus 2x equals 9 minus 2x. Alrighty, now this is a quadratic equation. How can I tell? Well, it's got that x squared in it. Quadratics, we in general want to get equal to 0. And right now, ours is equal to 9 minus 2x. So let's subtract the 9 and add 2x to this side and get them on the other side. So I like to draw my little dotted line here to keep track of sides. I got to subtract the 9, so that adds up to 0. But I got to do it to the other side. I've got to add 2x, so that adds up to 0, but I got to do it to the other side. So now my right side is 0, but my left side has morphed a little bit. It's now x squared plus 4x minus 8. And I forgot something, and the thing I forgot is that on our practice one here, this thing should have been a 6 right there. Otherwise, this equation does not do what I want. So I'm going to walk back through here real quick. I'm going to change this to a 6, change this 9 to a 6, change this 9 to a 6. I'm going to now subtract 6 from both sides, and that will make this a 5. Okay, super important to it. By the way, speaking of that, you know, if you want to come back up here, I had one other mistake in this problem. This was 3b. In 3b, this should not be too big like that. That was meant to be a 12 exponent. So make that correction when you try to solve that one. All right, back to our problem at hand. So now I'm down to this quadratic here. In quadratics, you could graph it and try to solve it that way. Look for those x-intercepts. But this is just a trinomial. And these are, you know, from Algebra 1. I need 2 numbers that multiply to give me 5. Whatever goes here and here has to give you this 5. So it's got to be a 1 times 5. That's the only thing that multiplies to give you 5. And they've got to add up to the middle term. So the 4, or the 5 and the 1 better add up to 4. So I want the 5 positive, the 1 negative, and then just double check it. Negative 1 times 5 is negative 5. 5 minus 1 is 4. So there it is, factored. And then I can set each factor equal to 0 and solve it. So I add 1 to both sides, x is 1. And I subtract 5 from both sides, x is negative 5. Now we do have to check here for extraneous solutions. So I'm going to check, so here's the equation. And so if I put in a 1, it'd be 1 plus 1. And would that equal, if I put in a 1 on the other side, just replacing this x with a 1 right there. Yeah, it checked. Okay, so when I plugged in 1, the left side equaled 2, and the right side also ended up equaling 2. Let me check the negative 5 now. And it goes negative 5 plus 1. Does it equal 6 minus 2 times negative 5? And right away, the answer to this is no, because the left side comes out to a negative 4. And I don't know what this side's going to come out to. We'll find out here in a second. But when I square root it, it's not going to come out to negative. Right? If the number under here is positive, it'd be a positive answer when I square root it. And if what's under here is negative, when I try to square root it, I get imaginary numbers. Okay? We can go ahead and see what it does give us. Okay, so 6 minus, I do the 2 times, negative 2 times negative 5, so it's plus 10. Square root of 16, square root of 16 is 4. You can see they do not match, so that's our extraneous solution. Okay, if you do try number 5b down here, it does not factor like this one factored right here. Okay, so you'd have to use the quadratic formula on it to solve that quadratic, or graph it and get approximate solutions. We don't have any like that on our test, so 5b you could practice getting up to this point, but then it would not give you practice in factoring. But on the test, this factoring method is going to come in handy. All right, 6a. Radical equation. How do I know? X under the radical. Is the radical alone? Yes, it is. And I know there's another radical, but I'm ignoring that. I don't care what the other stuff is. I'm going to focus on just one radical at a time, and I'm using this one. And it's all alone, so I'm going to square this side. But if I square this side, I square the other one. And since the other one is a radical also, and this radical is isolated, when I square this side and this side, both radicals disappear. I just get x plus 1 equals 2x minus 3. And then we just solve this guy. So I'm going to go like this, subtract my x's, and then I will add 3. 4 equals x, so x equals 4. And we're done. 7a, this is another radical equation. This is the same equation as this. This 5, remember, means fifth root. So it's fifth root of m minus 11. And then you got to raise it to the fourth power. So it is a radical equation, but we can work the radical equation in exponent form. Okay? Just like a radical equation, you get the radical alone, so you get the radical alone, this fifth root that we're dealing with, even though we're writing it as an exponent. So there we go, equals 81. Alrighty, now here comes the magic. I'm going to raise this side to the reciprocal of 4/5, which is 5/4. Why, you may ask? Because this creates a product of a product, or rather, a power of a power. So I have something raised to a power, and that's all raised to another exponent, another power. And the rule for power to power is you multiply your exponents. Well, since these are reciprocals, reciprocals automatically multiply to 1. You can see the top would give you 20, the denominator would be 20, and 20 over 20 is just 1. Okay? But if I do it to the left, I have to do it to the right, so I got to raise this side to 5/4. But the nice thing is, now that this multiplies to 1, I can drop all these parentheses, because it's just m minus 11 to the first power, and we don't show first powers. Now over here, you can use your calculator or your brain. We've already used a calculator to do a problem like this before. I'm going to grab it again to remind you. This will type in 81 caret button to the 5 divided by 4. And I hope it comes out even. Otherwise, I got to do a lot of work. And it does come out even. So 243. And then we'll just add our 11 to both sides to get our answer. So m is 254. There we go. So that takes care of those. That's your first 7 problems on the test. Now let's flip this over. Okay, number 8, find the inverse. So we change the f of x notation to y. we exchange x and y. So I change the y to an x, I change the x to a y, and then I solve for y. So there's what I'm trying to get alone. And I can see it's being multiplied and has this 12 added on to this side. So first I'm going to get rid of that 12 because that's easy to get rid of. Minus 12, minus 12. And I can't really, get x minus 12. I just write it as that expression, x minus 12. There we go. So now I just got to get rid of this negative 3/4. Well, we just kind of saw how to do that. We said if you multiply by a reciprocal, you get 1, and that's what I want. I want 1y right here. So I'm going to multiply by the reciprocal of negative 3/4. I'm going to use negative 4/3. Now that negative doesn't matter if you put it on the top or the bottom. It's a negative number times a negative number, so that will be a positive. And we already know it's going to give you 1. And we know it's going to give you 1 because we know how reciprocals work. Okay. Now don't forget, since I multiplied the left side or the right side times negative 4/3, I got to do this to the left as well. So let's see if we can track this work up here. So here's the right side. The right side is just 1y now. Here's the left side, negative 4/3 of x minus 12. And let's go ahead and distribute this thing. Let's see here. Now I got to do negative 4/3 times negative 12. Okay, I could get my calculator out for that, but I think we can handle it. Let's say let's just multiply like fractions multiply. On the top you get 48. On the bottom you get 3 times 1, 3, and that simplifies to 16. So this is 16. Okay, so that's our inverse function, and now we can use that inverse function notation. All right, so that's the inverse of this. Let's see here. Something seems a little bit... No, I think we're all right. Okie doke, let's do 9a now. 9a is the same thing. I'm going to erase this little scratch work I did to figure out that product. So let's see here. I'm going to go y equals 8 root x plus 3 minus 10. I'm going to flip-flop my x and y. I'm going to solve for y, so I'm going to add 10, just like I added on the other side, that 12 first. So I get x plus 10 equals 8 root y plus 3. I want to get that radical alone, so I got to get rid of this 8. So I divide this side by 8 and this side. On the left side, I just leave it like that. On the right side, now I just have a radical. But the radical now is isolated, so when I square this side, the radical will go away. I just got to make sure I do it to the other side. So I'm going to track it right up there. Here's the right-hand side now. It's just y plus 3. Okay, so I took this right-hand side and I put it on the left. And I'm going to take this left-hand side, I'll just put him on the right here. And he is just x plus 10 over 8 squared. And so my y is almost alone. I just got to subtract that 3 from both sides. There we go. Y is, this ugly mess. X plus 10 over 8 squared minus 3. And then we'll use our inverse notation. So there is our inverse. All right, 8b and 9b are just like that. Down here we have to graph. Now you get the choice of what you want to use, your graphing calculator or Desmos. I'm going to pull out Desmos. It works so much easier for graphing. All right, so here's my first graph. Y equals, and they've got the square root of x plus 6 minus 3. That's a terrible looking 6. There we go. And plus 3 minus 3. So I can get my stuff right here. Minus 3. There we go. There he is. So one of the key points you always want to find is this starting point for it. Now he's a little bit tough to find. There he is, negative 6, 3. What we could do here is rather than write it with y notation, we could use function notation. And then you could ask it to make sure. You'd say, well, I think, at x is negative 6. It looked like that's where that thing started. And so you could plug that in, and it goes, it's -6, -3, and that's what you think it is. You could even graph that point at this stage just to make sure. And you can see where it puts the dot right at the beginning of that. So I know exactly where it starts. -6 and -3. So right down there. And then goes up and to the right, and you can see it crosses the x-axis or y-axis somewhere there. So it just looks like this. We don't have to be too perfect with these things. We have a calculator if we want to be perfect. What we want is a general idea of what it looks like here, because we have to answer questions like, what's the domain? And once we get it graphed, as long as we can find this point here, which, by the way, remember, it looks like the parent function, which sits right here, but it's shifted left by 6 and down by 3. So really this point right here, we can figure out without a calculator. Okay? But we also want to know which direction it goes, because now we're going to do domain, and domain is saying, hey, what are the x values that get graphed? Well, in this case, when x is greater than what, -6, that's the first x value. No graph, x is less than, or over here at -7. So our domain here, we just say is x is greater than or equal to -6. The other way you could do this is just look at this radical. Remember, you can't square root negative signs. So if you ever want your domain, you just say, hey, I got to make sure that radicand, the x plus 6, is always greater than 0. And then you just solve that. Subtract 6. Look at that. I get the exact same domain. Okay. Let's try that on this last one here before I graph it. So I could take this x minus 2, ask it what makes you greater than or equal to 0. It answers x has to be greater than 2. Let's graph him. So I'll throw him right in here on my calculator again. And I'm just going to edit the one I have up there. So I'll make this -2. I'll make this +1. I can see it shifted it to the right 2 and up 1. I could ask it again. I think it's a 2 right here, so I could type in a 2. I could then graph that point to make sure if I wanted to. It'd be a 2 and 1. Okay. Or I could look at my equation up here and I'd say this goes right by 2 and it goes up by 1. Okay, but right 2, up 1, there it is, it goes up and to the right. I've got my domain right there. You can see x is 2 and it goes to the right, so greater than 2. All right, that should be everything you need. We did the front, all of that in the past couple of days, so hopefully you can solve the rest of those. Good luck on your test tomorrow.